let's just spend a bit of time having a look at the greenhouse gases. What exactly are they doing? What are they absorbing? What aren't they absorbing? So we're extending the picture I showed you earlier, where we've got the shortwave radiation and the long-wave radiation that's been re-emitted from the surface of the Earth. And in the next panel of this diagram, you can see the total amount of absorption that's taking place. And you'll see that the very, very short wave radiation from the sun is being absorbed, and then most of the very, very long emitted radiation is being absorbed. And then there's intermittent absorption in between. The next panel down shows the absorption patterns for water vapor. And you can see that water vapor will absorb some of the shortwave radiation, but it's mainly absorbing long-wave radiation. This is the radiation that's been re-emitted by the warm surfaces in the Earth atmosphere system. And what's really interesting about water vapor is that it's absorbing almost all of the very long wavelengths. The next one down is oxygen and ozone. And oxygen and ozone are doing their work in the stratosphere, in the ozone layer. And they are removing the very short wave, the high intensity, ultraviolet wavelengths that cause skin cancer. Methane doesn't absorb large amounts when compared with water vapor, but it is absorbing important wavelengths, and they are reasonably unique in terms of many of the other gases. Nitrous oxide the same. It's not absorbing a lot of wavelengths, but it absorbs in a very specific wavelength. And so we notice, when we look at the second panel in particular, that quite a bit of the shortwave radiation makes it down to the surface of the Earth. It's heating up the surface. The surface then re-radiates, and then that longer wavelength radiation gets absorbed by water vapor, methane, carbon dioxide, and nitrous oxide. But there's a window in the middle, and there's a whole bunch of wavelengths which just pass unimpeded back out to space. And we call that the atmospheric window, and all of that energy is lost back to space. We haven't yet found a chemical pollutant that will absorb that radiation, and perhaps that's a good thing, because if we do, we will upset the balance even further.